So
Alright.
I want to say good morning and welcome to day one of scalable smart safety. Today in this part one of a two-part webinar, we'll be focusing on enhancing the intelligence of simple safety solutions. For those of you I haven't met or don't know me, I'm Andy Restalis. I am the Industrial Control, Safety and Sensor Product Manager for HESCO. And with me today is Jim Drew. Jim is with Rockwell. He is their business lead manager for safety, sensor, industrial controls, mainly focusing in on a lot of time on safety. Jim covers most New England and some of New York. We work together as a team to cover Connecticut, and our main goal is to support you, our valued customers, in any of your safety, sensor, or control needs. Today's agenda, you can go forward there.
Sure thing.
Today's agenda, we're going to break it into 4 parts. Part 1 will be smart safety philosophies. In section 2, we'll be going into the safety life cycle. We'll then move into running through some safety products that can help us realize the smart safety vision. And then in section 4, we'll wrap up with going over some complementary tools that are available to assist you in the smart safety implementation.
All right.
Smart safety philosophy. What we see is that in manufacturing, there's a transition taking place. We're going from the old run until it breaks, where safety really is an afterthought, to the changes that are moving us from the old style technology and old style methods into newer technologies that are giving us, we are getting a lot more from the machines rather than just product. To what we expect today's standards to be, or we're building those into our machines, into our shop floors. Along with these, we're getting preventive maintenance, which provides diagnostics. We're transforming the plant floors with technologies that are modern. We have more modern platforms that we can build that are out there for us to design to. Something that we can leverage, of course, to collect data. Data is becoming a big focus on today's industry. We want to know what our machines are running, how fast they're running, what our downtimes are, because all this adds up to money that is coming out of the company's pockets. Also, with the change in technology is collaboration. This in nowadays is becoming more and more where, as we add automation, man and machines are working together. In a lot of cases, we have robots that are working on the lines alongside of us. So we need to take into account the safety for that. But the big key here is really, is it, you got to go to the next.
Oh, sorry.
That's okay.
I pushed the button, but it didn't move.
Yeah, we need to improve safety. So when we start talking about safety, there's the whole philosophy that has been shifting from the years past, but there's still many who equate improving safety to decline in productivity. If we put ourselves into this person's train of thought, we know that anytime we put our hands through a light curtain or open a door or push that e-stop, the machine stops. Anytime the machine stops, we're not producing anything. Therefore, if I am safer, I must be less productive. And this really is entirely untrue. It's really a myth. Providing safety actually increases productivity when done correctly. That is why we really need to look at the concept of smart safety with contemporary solutions, technologies, and methods. This will allow us to evolve to the point where we're not bolting safety on afterwards, inhibiting what the machines and the personnel need in order to run efficiently. We really need to integrate it in drive safety and we really need to integrate it in driving safety and productivity together. This is what we do today, and this is what our new perception should be. I want to go on to safety productivity. Safety is good business. So improving safety increases productivity. This is not just a theory. This is actually supported with real data. There was a company called Aberdeen Group. They did a study a few years back where they looked at a little more than 300 companies. With the data they compiled, they created this chart. Taking a look at it, you'll see that best-in-class performers in terms of OEE, OEE standing for overall equipment effectivity, which in layman's terms is a measurement for productivity. These companies were not only the best in productivity, but also in safety. We can see that the best in class scored 90% in OEE, only 0.2% in repeat accident rates, 0.05 in injury frequencies, and saw just 2% in downtime. What this spells out is that less downtime, higher safety results in higher productivity. You can read through the list and you'll see that from bottom to top, especially in the bottom, the laggers, their OEE safety and productivity records are extremely different than the best in class. This is all contributed to how safety is implemented. So it moves us towards what we say that, what does this really mean? How do we actually get there? What makes this happen? There's a basic 3 main buckets that allow this to occur. They are culture, which is behavioral, compliance, which is procedural, and capital, which is all the parts and pieces that come together to make all of this work. Each of these buckets have to be done and have to be equal, or the whole thing will tip over. It's kind of like a 3-legged stool. You can't have one shorter than the other, it just won't work. If you look at culture, every day there's someone in the plant floor or maybe at the equipment manufacturer who's making a decision to do something, either the safe way or not the safe way. So culture plays a big part in this. You need to change ways of thought in your employees and your designers. Compliance, obviously, are the standards and the requirements. They're there for a reason. We need to follow them, and we need to be compliant to them in order to make sure our plant floor or our equipment meets safety standards. This is reflected in a way that things are implemented. A quick example of this is those of you familiar with older cars of the past, will never go, if you know a Model T, they'll never do 130 miles an hour, but yet the speedometer still lists 130 miles an hour. It just can't get there, and the car is not designed to support that level of speed. So the same theory applies with our safety systems. If the system and the design can't withstand or provide what we need out of it, we will never get where we need to be or what we expect to get out of that plant floor, that equipment. In order to be successful, all three pieces have to come together and be equal to prevent or to give us a homogenized system. Okay, go ahead. The Safety Maturity Index. In laying this all out, Rockwell looked around for a while to try to find a way to quantify this, and ended up creating their own quantification because they just couldn't find anything out there that truly fit what they were looking for. This quantification is called the Safety Maturity Index. It takes into account the combination of where a company stands with the combinations of culture, compliance, and capital. They take these buckets, 3 buckets, and perform a calculation applying a relative scale to see where the individual company would sit in the maturity index. This tool is available to you, and it's on the Rockwell website. You can also see the link for it at the bottom of the slide. You can also find it if you Google it or whatever form of search media you're using. You just simply go in and type Safety Maturity Index Rockwell, and you should be able to get the link. It's a tool that actually is managed by a third party. So Rockwell never actually see your data. You are the only ones to know the data that you put in. Rockwell will only have access to the aggregate data so that they can see generally how companies are performing and how things are hopefully improving over time. We encourage you that you use this tool. You can, but only you can see the aggregate numbers. But also a nice thing about feature of this is you see the aggregate numbers of other companies or industries that are like you. So you can get a judgment of where you stand. You can weigh yourself against others that are in your same industry or same field. And let's see. So that finishes that, Jim. If you want to jump in here for a little bit.
Sure. Yeah, no. So kind of as Andy was describing, right? There's a 3-legged stool that we need to work with. But keep in mind, thus far, we've talked mainly about safety in general. We've touched on some of the value of contemporary solutions, but this is where we really get into the meat of things. Because at the end of the day, safety is the ante, right? We need to be safe. We all want to be safe. But again, that productivity equation, safety and productivity coming together more readily, is really based on how we implement our safety systems. So safety driven by our risk assessment and designed to the latest standards, that's kind of that compliance piece, a part of that compliance piece that Andy talked about in the Safety Maturity Index 3-legged stool. But really, it's all about the capital investment, or the pieces and parts that we use, which ones we select, that's going to drive the productivity piece. So that's really driven by the need for that flexibility in your system and the information that you can gather that allows you to make better decisions more rapidly, and therefore maybe minimizing any safety disturbances, but definitely minimizing overall any unforeseen situations, because if we can identify them early and act upon them, then they're not unforeseen anymore. So really, when we talk about intelligent safety or smart safety, it's at minimum information integrated. This is a two-part discussion. Tomorrow's discussion keys in a little more on fully integrated safety, but fully integrated safety is not necessarily the answer to all challenges. In terms of simple safety needs, where there's not a lot of devices, there may be perhaps not a lot of different zoning requirements or other things that we see with more larger solutions. In a simple safety solution, we still want to take advantage of that information. So intelligent safety is information and integrated at minimum. And in many situations, information integration is extremely valuable to an existing application. So we want to basically capture data, turn that into information, and then based on knowledge of what that information means, we can create prediction models and understand what's going to happen before it happens, and then take an action before anything occurs that we don't like, right? So that's really what this is really driving toward. So, and just a really simple example of this information flow and how it can be valuable, right? So if you look at a design of a machine or a line in a plant, and based on the design of that equipment, we have an anticipated exposure of every guard on that piece of equipment, on that machine, right? So even the simple data of how many times has that guard been accessed, how many times has that light curtain gotten interrupted, that information can be extremely valuable. It can be valuable not only from a safety perspective, but also from a productivity perspective, right? So let's talk about productivity perspective first, right? So if for example, we know that we need to break a light curtain every 5 times per shift or something in order to make the changes required to optimize production, and we're only doing it 3 times, then what's going on, right? What's happening? But similarly, if we have a guard door perhaps that we know is going to have to be opened 2 or 3 times a shift or a day, and the machine's been running and it hasn't been opened for a couple of days, or even 1 day, or even 1 shift, then that should send up some alarm bells, because if it's not being opened, perhaps, and the machine's still running, perhaps it's been bypassed. And that's something that's completely unsafe and something that we do not want to occur. So we can identify safety situations potentially, as well as potential productivity gain situations, just with the simple data that we're describing here. So there is safety in information, and having that information is going to drive us toward a better operating machine and ultimately a safer workplace. So with that, the other thing to touch upon real quick is the basic model. We don't want to go too far forward without doing due diligence and justice to understanding the safety lifecycle, because that is what is going to drive our decisions on everything we do. And Andy, do you want to step in here on this one?
Yeah, I'll take over, but I want to just let you know, put the panics aside. Jim said tomorrow.
Did I say tomorrow?
Yeah, that will be next week, not tomorrow. So don't panic saying I must have read it wrong. One of the major questions that we all ask about our designs and implementations of safety is, how do I know that what I've done is good enough? How do I know that it's safe enough? Because we can always go a little bit further, right? We can always put a little more into it. I can always change it. in different ways. So how do I know if it's safe enough? I would submit to you that the best way to know is if it's safe enough is to follow this life cycle. And what we do is there's 5 different steps. If you do a risk assessment and the actual documentary regimented risk assessment of the situation. And this would drive, so you do the risk assessment, which will then drive you to a functional requirement that says, based on your risk assessment, this is what we need to do. And when we design to that, and then we have to verify that, that our design meets the functional requirements. And I need to do, what do I need to do to meet the standards in this method? So we do a design and verification. And then we do the install and validation. So validation means that we really check to see that the physical implementation of the design really does not meet what the design and verification said that it was going to do. Then when this is all tied together, we know that we have done the best that we can. And of course, over time, things will change. We need to maintain and improve. If we implement a safety system on a machine today, doesn't mean that next year, next month, 2 years from now, that we can't change that equipment. We may speed it up to get more production out of it. We come up with new methods, and maybe we can speed up the whole line slightly. That means what does that speed change affect? It probably changes the stop times, and many things are tied into this stop time. If you have a light curtain or door switch, for example, you have the safety distance calculations that may need to be looked at. Settings with the light curtains, what is the setting? Do I have to change it for the reach distance before you get to the hazard? If I stick my hand into that light curtain, before it wasn't a hazard, now that I speed it up, now it may be a hazard. So we need to, with any changes, we need to go back and redo this risk assessment. So really increasing speed in machines that change the speeds needed to stop and change will also change the risk assessment. Actually, Jim, I think I kind of hacked this up here. You want to just—
No, I mean, I think you hit it well. I mean, the question is always, how safe is safe enough? And if we follow the standards and follow the life cycle, we will end up at a place that we all agree, as standard committees are made up of very typically very experienced and intelligent folks that drive those standards to make sure we're doing things the right way, and understanding what we need to do is the first step, right? So risk assessment, functional requirement, design verification, validation, maintain and improve. That's well said. So no worries. But moving on from the risk assessment, because that's going to get us, again, that base safety, right? That ante. And then implementation wise, we're going to have choices. For example, we have a functional requirement that says we're going to implement a movable guard. So we're going to have a safety interlock on that. Which one do I choose, and why? And that functional requirement is going to be functional. So it's going to drive a safety function. It's going to say the guard door, when the guard door opens, a safety relay interprets that and then shuts off an associated motor of some sort with a safety device. So what do I choose? What do I choose to really get farther in the smart safety journey? And that's where we're going next. So we're going to talk through some products that are really going to help us realize that vision of simple safety solutions that are smart and things that can provide us that value that we're looking for with information enabled or information integration, right? So, and we touched on this just a little, so we won't spend only a second on here, but keep in mind that all safety is a function in terms of anything that we're doing with a control system. And a function needs three pieces to work. It needs an input device, a logic device, and an output device. And we've all heard many times in our lives, I'm sure, that a chain is only as strong as its weakest link. So if we have a weak link in this chain, if we had as for example, if we had a functional requirement that said we were going to use a movable guard and needed an interlock, a safety interlock, and we were going to use a safety relay, et cetera, and we were going to need a category 3 structure and performance level D on our safety circuit. And I know we're not talking about those today, but just for argument's sake, even if you're not sure what those are, they're very specific requirements that are out there on the standards that say how to build the circuit and how it's going to perform. If we don't really follow that all the way through and we don't have the output device, as an example, meeting those requirements, it doesn't matter that the input device and the logic device are good. We've ruined our function by not completing the whole function. So that's going to be very critical. So we're going to talk through input devices, output devices, and logic devices as we go through here. And the technology changes we're going to highlight in some of these products as we go through is really, old way versus new way, I'll call it. So conventional solutions, things that we've seen in plants and maybe have in machinery of the past versus what we would do today that's going to help us. And where these things come into helping us is really in that they are different, right? Just like we have a rotary phone that used to hang on the wall, and now we have a cell phone, right? Things are different, and we make sure that we're looking at what's going to be the best fit and the value for the application. Generally speaking, conventional solutions of the past have been electromechanical devices, right? Dry contact safety switches, as an example, right? Now we'd like to forego those and really look at contemporary solutions that are solid state devices. There's a lot of benefits to that we'll talk through as we go through the product. Historically, we've had dedicated functionality devices. We really want to have configurable functionality that we can use as needed. And the device-specific safety relays are a great sub-piece of that, right? Whereas potentially, in the past, we had safety relays that only worked with dry contacts or only worked with light curtains, and you had a mixture of products all over the place. We really want universal inputs where we can, and we want to have those I/O configurations, be something we can work with in different ways. And the biggest pieces are right here, though. We want to get away from products that have limited information and diagnostics and move toward things that have those built in, because that is what drives a lot of the behavior that we'd like to have in our safety system with the information. It's all about understanding what's going on with the product. And the other piece of it is that when we get all the way through here, the conventional solutions and these electromechanical devices, we always have to be concerned with a probability of failure and life cycle costs or life cycle of the product itself. And electromechanical devices, the probability of failure is based on the number of times it's operated, and we need to track that. Whereas with contemporary solutions, that's not the case. The probability of failure is independent of those cycles. So that is a big deal in terms of maintaining the system. So we want to make sure that we're focusing on the newer contemporary solutions. So with that, this is a pretty broad spectrum of products that we would say these are our most highly contemporary solutions. You'll see on here a safety controller and safety over Ethernet. And we're not going to talk about that today. That's for tomorrow's discussion. Today, we're going to zero in on these devices right here. And you see our controller just turned into a standard controller. And by the way, you see on the Ethernet line, you see dotted green here. That means that is not a safety connection on Ethernet, but an information connection on Ethernet. And then of course we have the devices below that are going to drive the information into the control system and out of the control system that we're going to touch upon as well. So let's start with input devices. Let's go down the chain. Just generally speaking, a broad topic of contemporary safety devices is shown here. I mean, anything from standard RFID interlocks that we call SensaGuard to locking versions of different types. And we're going to touch upon a couple of these that have been recently introduced. But we wanted to at least provide a broad spectrum that there are a multitude of solutions in this space that are contemporary solutions, right? There's nothing with dedicated controllers. They have OSSD outputs like a light curtain. But they do, like a light curtain, also have self-checking advanced diagnostics. So, you know, you look at a standard electromechanical device and you have a dry set of contacts moving back and forth with a cam inside a switch driven by that key that you just plug in the hole. If you think about that, you have no idea that that switch is going to work. Absolutely no idea until you put a demand on the switch. You don't know if it's welded. You don't know if it's physically broken. All you know is that you have those two contacts sitting in the right place there. And actually, you don't even know that. You really know that you have those two terminals shorted together. But either way, the point being that that switch does not really tell you very much at all. It really doesn't. And what we have also there is no information, right? We have no LED indication or anything. We don't really have anything. We have an auxiliary contact, which arguably also doesn't really tell you anything either on those switches. So what we really need to do is look toward these solid OSSD, you know, self-diagnosing, advanced diagnostics type products that have the LEDs and information that we can use that help us. The other thing I'd note here also is that, and again, we're not talking standards, but there is a relatively new standard out called ISO 14119 that talks a lot about understanding the risk and the motivation to defeat in an application and what to do about that. And that includes in the standards the use of what they call low coding, medium coding, and high coding for the actuators. So ultimately, if you have a standard key switch with a key, that is now considered a readily accessible tool and is not acceptable in an application where there's a high degree of motivation to defeat. So long story short, though these contemporary solutions drive you into different places and different functionality that you can use. But again, focusing on the information, which is why we're here for this smart piece, these are going to provide you the LED indication status at minimum and some other functionality that we'll talk about in a little bit. That really can get you into a different place in terms of knowledge. So the first product that we'll touch on in a little more depth, and again, we're not going real deep on any of these products, but getting you some visibility to them. This is a product that came out only 6 months ago or so, I'm thinking. It's a 440G EZ. E is for electromagnetic. Notice it is not called a guard locking switch, it is an electromagnetic safety switch. So effectively, it is a RFID-based, OSSD-based intelligent switch that also has a locking function separate from the safety function. So this magnetic locking function, obviously being electromagnetic, is power to lock. As you see, 500 Newton holding force. It has really good tolerance to misalignment and does get you to the highest levels of safety. Keep in mind, and everything in red, by the way, is what I would consider key information. The 14119 3.29 down here, as you see, this is for protection of the process, application of guard locking to protect the working process from being interrupted. So generally speaking, or actually even specifically speaking in that standard, it specifically indicates that power to release switches are used for personnel protection, power to lock are used for process protection, if you will. But again, nice big bright LEDs down here on the bottom that don't show up well in this picture. But there are some LEDs down here that provide you indication of what is occurring at the switch. On the 8-pin version, you also have some auxiliary outputs that you can drive to I/O points to give you additional information. So it's really about the information as well as the functionality of the switch. Second one to key in on here is also a relatively new product. This has been released in maybe the past 6 months as well, maybe a little less. This is the 440G MZ. So this actually is a guard locking switch, either power to release or power to lock. You see the holding force is far more than the prior product, 2,500 newtons holding force. Similar misalignment tolerance, which is key, right? The way this switch works is it actually has a bolt that fires up through the hole that's in that actuator. You see right here, there's an actuator hole, and that goes into the switch, and the bolt fires up and prevents that actuator from moving. Highly flexible actuator in nature for sliding doors, hinge doors, just make sure that it aligns very easily. Again, having those standard or lower high coded, if you will, we call them standard and unique because we actually had those names out before the standard was written. But ultimately allows you that flexibility. And again, all the LED status you can ask for and more. This is actually the first switch which has a direct to Guardlink connection. We have not talked about Guardlink yet, but we will. And this is a key thing to note, and we'll come back to this a little later. But this is it's a really nice switch. It has a nice slim body design, which is really good for those 80-20 type strut applications. Just a really, really nice switch to utilize for door locking. And for those of you who may look at that switch and go, hey, that looks kind of similar to something I've seen before. You said that's brand new. Well, that's because the body of the switch is effectively same physical size as this product here, the GLZ. So the LZ, I wanted to put them side by side so you could see the differences here. The LZ has a much smaller holding, well, about half the holding force, is not much smaller. But the key here is the misalignment tolerance. The LZ is really designed for those smaller doors that are much more controlled in terms of the misalignment that they may experience. And it's optimized for that whole partial body access due to that, right? Smaller doors that are more manageable for sag, et cetera. Whereas again, the MZ, optimized for whole body access or larger doors because of the misalignment, the holding force, et cetera. One of also the key things here is the way that the actuator is structured. So this actuator is a floating actuator. So this will move up and down away from the switch and eventually get far enough away where the switch won't like that anymore and it will present a fault. Again, that's why this is really optimized for those smaller doors that we can control the amount of movement. But the other thing to note is that this one, the way this works, this has a magnet on the top of this bolt. The MZ does not have a magnet. It uses an inductive coil for like a prox, if you will. But effectively, both of these work the same way, and these are very intelligent switches. So what happens is this actuator or this actuator come in place, and the switch identifies that actuator based on an RFID tag that's in there. And then what happens is it says, okay, I see that RFID tag. I know that the actuator is in position, and then the switch will fire the bolt to lock. When that bolt goes into the actuator, there is a mechanism whereby the actuator releases a second code that the switch actually reads. So now that it knows that the actuator is in place and the bolt is actually in the hole, it knows both of those things from a safety perspective. So that's very, very different than an electromechanical device that you're moving cams and shoving things around and moving dry contacts. So very, very useful to know. Okay, so kind of switching gears to a whole different product. Something to draw attention to here is this Lifeline 5, which is effectively a rope pull switch, if you want to call it that, or a cable pull switch. Similarly to what we've been describing with information enabled with LEDs, there's also a physical output on the 8-pin versions that will tie into this tension LED that we'll talk about first. So you can actually not only get the LED, but you actually get an output doing the same thing. For those of you who may have worked with products of cable pulls previously, They have a cute little window that you have to like really squint to look at to see a little red line or a blue line to know if you're in tension. And in order to do that, it's usually a two-person job, although if it's a one, you're back and forth, back and forth, back and forth when you're tensioning the cable and trying to monitor whether or not it's at the appropriate tension level. With this particular product being, again, an intelligent device with all those self-checking advanced diagnostics, et cetera, this is actually a strain gauge. It's not moving contacts, it's a strain gauge. And when we get the right strain on here, if you will, then, or the right force on the strain gauge, then we know that we're in the tension window. So how we know that is this nice LED here, this big bright LED will flash at us, and it'll flash faster and faster and faster and faster as we get to the right tension, and then it'll stop. And then we know we're in the right tension window. Very, very simple and very, very highly visible. Again, LED indication, green for I'm as good as a switch, red for I'm tripped. But the nice thing about these diagnostic pieces of information here, and again, both LED and also an output if you want to use it, this will start flashing when you come out of tension. When you're starting to come out of tension, when you're just starting to come out of tension, the switch will not stop. It says, hey, I'm gonna have a problem, come fix me, before it has a problem. So that's that whole predictive diagnostics that Andy touched on, and how that we can avoid downtime by understanding what's going on with the switch before it shows an issue that prevents us from running. So that's a key thing to realize with these types of products. The newest family of light curtains, the 450L, I want to touch on that briefly as well. That's a light curtain's been out for a little while now. And there's a couple of different versions, a basic model that's on-off only, an enhanced version that does, fixed blanking, floating blanking, reduced resolution mode, muting, et cetera, cascading, et cetera, et cetera, et cetera, and also has a laser alignment function built in. But all of these products are really very intelligent. They're very intelligent. They have the nice LED status we've been talking about right on the stick. You can't really see it here, but it's on the face of the stick. But where these really shine in terms of intelligence is after the fact troubleshooting, if you will, for the simple application. We'll talk more tomorrow about other capabilities. But one of the things that you can do with these products that's very unique and interesting is you actually have an optical interface that can tie into this curtain. And that optical interface will allow you to actually pull fault codes out of the device. If something happened and we don't know what it was, we can look inside the curtain and see what did happen. We can also identify what beams are broken, the strength of the alignment, of what beams maybe have different optical strengths, et cetera. All just looking on within some software, the CCW software, if you're aware of that. Allows us to go in and grab information out of the stick. And these are also very unique in that they are a transceiver. So each stick is actually exactly the same, whether it's an emitter or a receiver, is based on the plug-in module that is plugged into the base stick. So it's a very unique, patented, novel technology solution that provides a lot of value. And just touching on laser scanners quickly, because we do see this as a big win for intelligent safety. Again, these diagnostic pieces, right? And even beyond that, in the application space, these things have multiple zones that you can configure. There's a safety zone, but there are also warning fields or warning zones. So we can take advantage of that in our simple applications or even our complicated applications by setting a warning zone that maybe gives somebody a warning before they actually step into the protective field and shut the machine down, right? So we can provide those functionalities with this product that really, really does, again, enhance that productivity piece, right? Because many times, and I've shut down things before when I'm walking through plants. I admit it, I do. I've stuck my hand in places where it shouldn't be and shut a line down. So, but if there were some indication that that was going to happen before it happened, obviously that would not have occurred. So those kind of pieces of information are extremely useful. And even such a simple thing as an e-stop, quite frankly, I see so many e-stops out there that have no illumination. And most of our e-stops on equipment are in series, right? And we talked about the in series stuff a little bit ago. And if you have a bunch of dry contact devices, e-stops still have to be dry contact based on the standards. If you have a bunch of e-stops or dry contact devices in series, make 8, 10, 12 of them with no LED indication to determine which one is having an issue or which one may be open or pressed, it makes it awful hard to find sometimes when you're actually going out and trying to figure out what's going on. So having that, again, that indication is key. So there's a set of products that we offer that are configured with connectorization and illumination to really make things easy, because that connectorization ties into a couple of what I call Lego sets to pull things together easily. Lego set number 1, again, we're focused on these contemporary devices, right? So our indication is going to be on the device itself. We're going to have LED indication of status, etc. But ultimately, this is just simple wiring inside these taps, but it's all going to be simply done for us, plug into the relay, and all the safeties are in series, but we get all the indication, the visual indication via the LED diagnostics on these switches. So that's at Lego set number 1. Lego set number 2, we say, well, we really want all these safeties in series, but we really want individual enunciation back from each of these devices. So one of the ways that we can do that is through Lego set number 2. All the safeties again are in series, going back to the safety relay, but each individual auxiliary is brought back to IO points in a safety PLC, or sorry, in a PLC, not a safety PL. It could be safety, but more often than not, we're talking simple applications. We go to a safety relay and we pull these into the standard PLC. Again, getting those diagnostics not only at the switch, there's also diagnostics on the box in this case with the LEDs, and then obviously the information to the PLC puts it wherever we need it to go. So those are good. Those are actually great, and they help us a lot. But what if, right? So what we really want to do is we really want to do all that informational stuff without wiring. And that's where Guardlink comes in. So stepping back, we talked about the 440G MZ switch and how it was the first switch on Guardlink. Well, now we're going to talk through Guardlink so we can get a better understanding of that. Right, so Guardlink is effectively a trunk and drop system where we put devices in series with smart taps, let's say, and these smart taps will accept any safety device, whether it be electromechanical or OSSD. There's different part numbers for those two styles of switches, but there's taps to accommodate. And ultimately, we can get up to 32 of these in series per link. So you can imagine we have 32 e-stops maybe all in a row, right? And we can get these all on these smart taps. So what happens then is, well, how long can I go, right? Well, you can go up to 30 meters between devices, and I got 32 devices. So that's about 1,000 meters and 10 meters from tap to device. But really there are 2 links on each of these Guardlink enabled safety relays. So these 2 links, then you have 64 devices and 2,000 meters, right, is your max. And we'll maintain the highest level of safety, even being in series, which we didn't talk about, but there's limitations to that when using dry contact devices. We could put dry contact devices on each one of these taps, maintain PLE. But really, the magic comes in when we put the little gray box on the side. So gray is not for safety, gray is for information. And gray box then communicates over Ethernet to our PLC all the diagnostics and the status of each one of those taps, or ultimately each one of those devices connected to the tap. And that's all very simply added into via the add-on profile into Logix. And not only do we get the diagnostics, we also get the capability to remotely reset any switch if it's an intelligent switch that experiences a fault and needs a reset. We can do that. We can lock and unlock doors. We can reset the relay. We can do all that stuff all over the network with no additional wiring. So that is a big win for those simple safety solutions with respect to information enabled, right? And the devices themselves, we've talked about them as being smart taps. Well, they're only a smart tap if you have a dumb device. If you have a smart device, they can be a dumb tap. So this 440G MZ switch is the first switch that's available direct on Guardlink. That means that it needs a dumb tap. It doesn't need an intelligent tap because the intelligence is in the switch. And in this particular case, we get the benefit of many more diagnostics because now we're looking directly into the switch. So now we have such things as whether it's ready to lock, how many times have I tried to lock or unlock, what's the voltage I'm seeing, is my actuator paired or not? There's a whole bunch of different things, and you see them all here in red, that really come into play when you start using smart devices on Guardlink. So this is the first, but it's not the last. There'll be many more devices on Guardlink. And this is great value to that kind of simple device intelligence piece. And the Guardlink relay, it's called the DG, is part of the suite, if you will, of Guardmaster safety relays. So that Ethernet module that we talked about right over here, that really ties into all of these products. Up to 6 modules can get all that information directly over to your controller. And the other thing I would note on here is that, I think most people may be aware of the GSR relay. It's been out for a little while, but I'll give you a quick commercial in that there have been some additions that you may or may not be aware of, which is the GLT, T for timer. So there's a timing version where you can do a category 1 stop all in one device right here. There's also a GLP, P for proximity sensors, which is used for safe limited speed or stop motion detection, standstill detection. So there's a few things that have come out that may or may not have some visibility. But effectively, this is my, I like to call it my Saturday Night Live relay, but sometimes depending on the age of the person I'm talking to, they don't understand that. But there was a skit a while ago, it's a floor wax, it's a dessert topping. It can do many things, right? So this can either be a standalone relay, it can be a modular relay system. You can logic between all these relays. The delay module, you can do on delays, off delays, one shots. You can do almost anything you want with these GSR relays. They're very, very impressive. But the big magic again is where you bring it all into logic and get all the information that you need and want for your applications. And this is really the first of 2-prong kind of product set, if you will, for the logic piece of this. And the second one is the CR30 product, which is, again, information enabled, information integrated with logics through an Ethernet plugin module. And again, this is not a completely new product, but it has had a lot of additions over the years. If it's something that you hadn't seen or haven't looked at, I'd encourage you to look at it again, because there's been a lot of improvements, additions, et cetera, to its capabilities. But the biggest thing here, when we're talking about the intelligent safety for smart, simple applications, it's really about the ability to communicate all those pieces of information directly to your control system. And that could be, it's mainly logics is where we see, but it's also into our Micro 800 family. It's just goes right into that as well, enabling that information to pass to your control system so you can make better decisions, good decisions, and be safer and better. And the last piece of product, just to touch on, is the safety contactor line has been expanded. We have safety contactors now from 9 amps to 750 amps. These are purpose-built contactors. There are very specific requirements around contactors when used in safety circuits. And these have all those and more. So I would encourage you to always look at safety contactors when you're looking at switching motors, et cetera, or pulling power with dry contact devices. These days we do see a lot of safe torque off application, right? Where we're hitting a drive, if you will, pulling safe torque off outputs off a drive, whether it's a servo or a VFD. But there are still many, many applications where these contactors are going to come into play. And again, I would highly encourage you to make sure that you're using the ones that are purpose-built for safety. Okay. So we only have a couple minutes left. I want to be very cognizant of your time, and we should be able to finish up here within the next couple minutes. The tools, we wanted to touch on the tools a little bit to make sure you had some awareness of the key tools that were out there to help you. The first thing is, if you are a ProposalWorks user, and if you're not, I would Google ProposalWorks and or talk to Andy or myself or any of the Rockwell or HESCO team, and we can set you up with that tool. But that is an extremely useful tool for product selection. But within that, there are sub-tools, and one of them is the Safety Lifecycle Toolkit. And this Safety Lifecycle Toolkit, as you see, has linkages to risk assessment software that we offer, as well as a safety automation builder program that allows you to do the validation verification to the standards as to what your circuit is going to achieve based on the parts you use, et cetera. And that ties into a tool called Systema, which also is linked here as well. And again, more on those tools. If you have an interest in those, we can definitely go through those with you. That's like at least an hour discussion in itself, but they are right there at the ready for you within that tool structure. The big one though that I would point to is what we call safety function documents, and we will get you a copy of this presentation, but you see there's a link right here. You can also use the Google machine or whatever search function that you like, Rockwell safety functions, and you should find them. But these are excellent. They literally give you everything you need for each safety function. So, the description of what the function does, setup, wiring, bills of materials, wiring diagrams, hardware configuration, anything you need to set up and how, verification, validation plans. It actually gives you the whole calculation for performance level. It basically gives you everything you need to implement that solution. So those are highly, highly recommended. And then the last piece of tools for you to be aware of is, and I know we're not talking about the standards today, but really the root of it all is to make sure that we're doing things the right way, driven by those standards. And this book is a great resource to leverage, to have a good understanding of those standards. It walks through a lot of those puzzling things sometimes that folks scratch their heads on. It this does a nice job of walking through it. It's a Reader's Digest kind of approach. It's not hard to read. It won't put you to sleep, at least not too quickly. It's pretty good. So with that, Andy, I think we're on our closing thoughts. The intent of this was really to try to key you in on some different ways to think about safety with intelligence, and using those contemporary solutions with the LED indication at minimum, and pulling the data and diagnostics into the controller as much as possible to get that smarter safety application, adding that layer of intelligence around that base, right? That's really what it's all about. And the smart safety devices really help you do that. And again, we just touched on some of those tools that help you as well.
So,
close us out, Andy. There you go.
I just want to thank you all for joining us. Hopefully you've walk away with this with some knowledge, and it's helped you in your next steps in your next project with safety. And Jim, thank you for